All right, welcome to The Explainer. Today, we're going to tackle a really big topic, network security architecture. Basically, we're talking about how we build these digital fortresses to keep our data safe from all the craziness out there on the internet.
So that's the big question, right? How do you keep the danger out? Well, to really get our heads around it, let's start with a problem from the physical world. And believe it or not, it gives us the perfect blueprint for a digital solution.
So the idea is pretty simple, right? You've got this super thick protective wall, and it stops a fire in one house from just ripping through the whole row. And that exact concept, creating isolation to protect against something dangerous, that is the absolute bedrock of network security.
Okay, so let's really dive into this whole idea of a digital firewall and see how it works as like the main bouncer for our entire network. So just picture a security guard, a really serious one, standing at the only door to your network. Their job? To check the ID of every single piece of data that tries to get in or out. They've got a list, and if you're not on it, you are not getting through.
The most basic way this works is something called packet filtering. And honestly, it's a lot like a mail sorting facility. The firewall looks at the envelope, which is called a packet header, checks the to and from addresses, and then, based on its rulebook, it either says, yep, you can go, or nope, you're out. It's super fast, but it has one major blind spot. It never, ever looks inside the envelope.
And this is where the tech really had to evolve. I mean, packet filtering is fast, sure, but it's totally blind to what's inside the data. The next generation, which is called stateful inspection, is way, way smarter. It doesn't just glance at the address. It actually rips open the envelope to see what's inside. It understands the context of the conversation, which makes it a whole lot harder for something nasty to sneak past.
Okay, so this next piece of tech it's kind of the unsung hero that's built into basically every home router you've ever used. It's called NAT, and it acts like a receptionist for your entire home network. See, to the outside internet, all of your devices, your phone, your laptop, your smart TV, all of it, they all look like they're coming from one single address. This makes it almost impossible for an attacker to single out one of your devices. To them, your devices are pretty much invisible. So a single firewall, it's a fantastic start. But a real digital fortress? Well, it's not just one big wall around the outside. It's more like a castle, with a bunch of internal walls and secure zones. And this whole idea is called segmentation. The first attempts at this were pretty bold. The strategy was to take one super hardened server, called a bastion host, and just stick it right out there on the public internet to face down everything. I mean, it worked to protect the internal network, but wow, what a risk. It was a single point of failure. If that one server got hacked, it was game over. So then the architects got a lot smarter. Instead of just thinking in and out, they used a single, really powerful firewall to create a third zone, kind of a middle ground. This buffer area is often called a DMZ, which is short for Demilitarized Zone. And this is where you'd put your public-facing stuff, like a web server, keeping it safely walled off from all your really sensitive internal data. And this design, it pretty much became the gold standard for a ton of organizations. By using two firewalls, you create these really clear security zones. You've got the red zone, the wild west of the public internet. Then traffic has to get through the first firewall to reach the yellow zone. That's the semi-trusted DMZ. And then it has to get through a second firewall to get to the green zone, your super trusted internal network. This is what we call defense in depth. If an attacker somehow breaks through that first wall, there's still another one waiting for them. Okay, so our fortress is locked down tight. But what happens when your own people need to connect to it from the dangerous outside world? From a coffee shop or when they're working from home? Well, that's where VPNs enter the picture.
So think of a VPN like this. It's your own private, armored subway car that's running through the public transit system. Everything happening inside your car is completely encrypted and hidden from anyone looking. So even though you're technically using the public internet, all your data is traveling inside this secure tunnel. It's totally confidential and protected from any nosy eavesdroppers.
But, and this is a big but, here's the double-edged sword. That exact same super powerful encryption that's protecting you, well, attackers can use it too, to hide their malicious activity. As soon as they're inside that encrypted tunnel, it becomes incredibly difficult for security teams to inspect what they're doing. It's a classic case where a technology's greatest strength is also a huge potential weakness.
So, okay, we've built our fortress, and we have a secure way to get in and out. But what happens when the whole idea of a single fortress just doesn't work anymore? What do you do when your users and your data are literally everywhere, at home, in the office, spread across the cloud?
This is where SASE comes in. It stands for Secure Access Service Edge, and it's a completely different way of thinking. Instead of dragging all your traffic back to a central fortress just to check it, SASE flips the model. It moves security out to the cloud, and it delivers it right to the edge of the network, wherever the user or the device happens to be.
Yeah, the real magic of SASE is this idea of convergence. It takes all those things that used to be separate, all your security tools, your networking functions, the smart ways you route traffic around, and it combines them into one single intelligent service that's delivered from the cloud. This makes your security way more flexible, way more scalable, and honestly, it's just perfectly built for the world we live in now, with remote work and cloud apps everywhere.
And this huge shift, it really leaves us with a fascinating, kind of mind-bending question to think about. Those digital walls we've spent decades building, they're basically dissolving. They're being replaced by these intelligent services that follow our data no matter where it goes. So the security perimeter, it's not a place anymore. It's becoming an identity.